The next topic is calculation of cell potential using the Nernst equation of the concentration cell. Now before that, we shall know that what is a concentration cell. Now it is a cell in which both the electrodes are of same type, but the solution of electrolyte in which they are dipped have different concentration. Now you can see in the diagram that we have got two electrodes. They are the same electrodes, that is of same metal, and they are dipped in the same electrolytic solution, with the only difference that the concentration of the ions in both the half cells is going to be different. Right? Now at the oxidation half cell, or we have taken it is C1m, that is the concentration of metal ion is C1m, and that on the right hand side, that is reduction half cell, we have taken it to be C2. Now we'll write down the cell representation. M, that is in solid state, half cell Mn positive, its concentration is C1m. Then the salt bridge, Mn positive, C2, that is a molar concentration of Mn positive, half cell M in the solid state. Now we'll write down the individual reaction for the anode and the cathode. Now M solid arrow mark Mn positive, this Mn positive is C1. Now since both the the electrodes are same and the metal ions which are in the solution is also the same, that's why we only way to differentiate between these two ions is through their concentration. That's why we are writing along with the Mn positive C1 and C2. Right? Now at the cathode we have Mn positive C2 plus n number of electrons accepting and forming M solid. Now M to M solid state cancelled out, n electrons with n number of electrons. Now we'll write down the net cell reaction. It is Mn positive C2m gives Mn positive C1m. Right? Now from the Nernst equation, we have E cell equals to E naught cell minus 0.059 upon n log product concentration upon reactant concentration. So it is C1 concentration of metal ion upon C2 concentration. Now what we will write in place of E naught cell? We will write here 0. Why, students? Because these are the electrodes of same metal, and while putting the formula E reduced minus E oxidized, we will get the same standard electrode potential values, and it will come to be 0. So E cell equals to minus 0.059 upon n log C1 upon C2. I think this much is clear. Now we can have two cases. Now the case 1. Assuming that concentration of electrolyte at anode C1 is greater than the concentration of electrolyte at cathode compartment C2. That means C1 concentration is greater than C2. In that case, students, C1 upon C2 will have greater value than 1. So log C1 upon C2 will have positive value. Right? Because C1 upon C2 is greater than 1. So log 1 will have the positive value. So E cell will be equals to minus 0.059 upon n into certain positive value. Now minus plus minus. So what is the EMF of cell? It is coming negative, and you know that whenever the EMF of cell is negative, it is not going to work. It will not be useful for us, as it is not feasible. Now we will see the case 2. Right? Now here we will assume that the concentration of electrolyte at anode C1 is smaller than the concentration of electrolyte at cathode C2. That means C1 is less than C2. Then C1 upon C2 will be less than 1. In that case, log C1 upon C2 will have the negative value. So E cell is equal to minus 0.059 upon n log C1 upon C2. Now we will put the value of log C1 upon C2. So it will be having certain negative value. So minus 0.059 upon n, and that multiplied by that negative value. So it will come E cell equals to plus 0.059 upon n. That means we are having the EMF of cell, that is a concentration cell, in this case positive, so it is feasible. So it means that whenever we are designing or we are preparing a concentration cell, right, now we will design it in such a way that the concentration of the electrolyte at the anode should be smaller than the concentration of electrolyte at the cathode, right? Then only the reaction is going to be feasible. Hence, at the end we can conclude that in concentration cell, oxidation occurs at anode whose electrolytic concentration is lower, and reduction will occur at the cathode whose electrolytic concentration is higher, right? So that means C1, where C1 is less, lower value, that is the oxidation half cell, and C2 is a concentration whose value is higher, right, and there the reduction will take place. Again, that is simple, that the oxidation will occur at that compartment where the electrolytic concentration is less, right, that is C1 will be having lesser value than the C2.